In this question, he is asking that if for the complex numbers z satisfying this condition, maximum value of this is attained at a plus ib, then the value of a plus b is equal to. First of all, I will tell you the geometrical meaning of mod of z1 minus z2. That is, if this is a point A, this is a point B, and here it is z1, here it is z2, then this thing represents the distance between the points A and B. And now clearly this means mod of z minus 2 plus 2i is less than equal to 1. That is, distance of z from 2 plus 2i is less than or equal to 1. Two plus 2i is somewhere here. This is a circle with center 2 plus 2i and radius 1. All the points on the boundary and inside will be at a distance of 1 or less than 1. That is, this inequation represents all the points on the boundary and inside. And this thing can be written as that is 3 into mod of z minus 2i, and this means distance between z and 2i where z lies anywhere on the boundary or inside. 2i is clearly somewhere here, and it is also clear that out of all these points, this point will be at maximum distance from the point, say A, say this is B. Clearly, this point will have fx 3 plus 2i because this point is 2 plus 2i and radius is 1. Hence, we can say that when z is equal to 3 plus 2i, at that time this will be maximum, and z equal to a plus bi is given. Therefore, a plus bi is equal to 3 plus 2i implies that a is 3 and b is 2. Hence, at that time a plus b will become 5. Hence, we can say this will become, hence we can say if this is maximum when z is a plus bi, and for this to be maximum, a plus bi should be 3 plus 2i. Hence, I can say a plus 5 be equal to 5. In this question, he is saying that if z is a complex number such that z minus I upon z minus 1 is purely imaginary, then the minimum value of mod of z minus 3 plus 3i is. Before I do this question, first I will tell you the concept which is going to be used in this question. Suppose these are two lines intersecting at a point A whose fx is z1, B z2, fx of C is z3, and I want to find this angle. Remember that whichever angle you want to find, make first anti-clockwise direction in it, and now after that write argument of, start from the vector from where the angle is starting. That is, you will write AB vector in the denominator and AC vector you will write in the numerator. and whatever is the argument of this, that will be equal to this angle. You have to remember this thing. That is, you can say argument of z3 minus z1 upon z2 minus z1 theta is this angle. And now because it is given that this is purely imaginary, it means argument of this will be pi by 2 or minus pi by 2. It is clear that the figure found will be iota will be somewhere here, 1 will be somewhere here, and because it is purely imaginary, it means the argument of this will be pi by 2 or minus pi by 2. Hence I can say locus of z will be a circle. Locus of z will be a circle for which 1 and I will be the end point of diameter, and that circle will pass through the origin. On what basis I am saying this thing? See, first let me draw the circle. Let us name the point as A, B and a variable point P on the circle. Complex number of the point P is Z. According to this, argument of BB vector upon AP vector will be plus minus pi by 2. And we know that angle in a semicircle is always 90. If I take the argument as pi by 2, for pi by 2 you will get one semicircle, either this or this, and for minus pi by 2 you will get the other semicircle. Otherwise it is not required to discuss that for pi by 2 this part of the circle will be there or this part of the circle will be there, and for minus pi by 2 which part of the circle will be there. But for crystal clarity, I would like that you should know this thing also, that for pi by 2 you will get this part of the circle or this part of the circle. See how this is AP vector, this is BB vector, and angle has to start from AP and reach at BP, and the direction should be anti-clockwise. For this portion, what is happening is, if I start from AP, go up to BP, this angle, this direction is clockwise. Therefore, I can say for minus pi by 2, I will be getting this part of the semicircle. For pi by 2, I will be getting this part of the semicircle. Clearly, if I take the point P on this part, situation will be something of this type. In this case, P is here. Again, you can see very easily now, for pi by 2, I will be getting this part of the circle. See why. If I extend this, angle start from AP, go up to BP, this direction is anti-clockwise. This part of the circle you will be getting for answer equal to pi by 2, and this part of the circle you will be getting for answer equal to minus pi by 2. But as a whole, for plus minus pi by 2, you will be getting the complete circle. That is, this will become purely imaginary if Z lies anywhere on this circle. And clearly 3 plus 3 iota will be somewhere here, and you have to find the minimum value of this, means minimum distance between Z and 3 plus 3i. Z lies anywhere on this. Minimum distance between Z and 3 plus 3i will be there. For that, join this with center of circle center of circle will be clearly midpoint of AB, that is 1 by 2 comma 1 by 2, and after joining this point with center of the circle, this distance minus radius will be giving you the minimum value of z minus 3 plus 3i, because for this point the distance from 3 plus 3i will become minimum. And to find the distance now, let us name the point as C, D, E. Clearly CD equal to CE minus DE. CE is clearly 3 minus 1 by 2 whole square plus 3 minus 1 by 2 whole square, minus DE is clearly root 2 by 2, because it is easy to see that the radius of this circle is root 2 by 2. This is equal to root 2 into 3 minus 1 by 2 minus root 2 by 2, that is root 2 into 3 minus 1 by 2 minus 1 by 2, that is 2 root 2. Hence I can say D is the correct choice. In this question, it is given that let Z1 and Z2 be two complex numbers such that argument of Z1 minus Z2 is equal to pi by 4 and Z1 comma Z2 satisfy the equation mod of Z minus 3 equal to real part of Z. Then the imaginary part of Z1 plus Z2 is equal to. Before I do this question, first I will tell you the geometrical meaning of argument of Z1 minus Z2. Suppose this is the point A, this is the point B, and you must be knowing that Z1 minus Z2 means argument of BA vector, because BA vector means complex number of the point A minus complex number of the point B. If it is Z1, it is Z2, then argument of Z1 minus Z2 means argument of BA vector, because BA vector means fx of A minus fx of B, that is Z1 minus Z2. And argument of BA vector means, first thing is direction is downwards. If I extend it, it is in downward direction, and we always deal with positive direction of x-axis, and angle always starts from positive direction of x-axis. Whatever is this angle, suppose this angle is say 140 degree, then argument of BA vector will be minus 140, because direction is clockwise. This is the geometrical meaning of subtraction of two complex numbers. This thing you already must be knowing. Mod of Z1 minus Z2 means distance between the 2 points whose fx are Z1 and Z2. That is, if this is the point A, Z1, this is the point B, Z2, mod of Z1 minus Z2 means distance AB. The first question which arises in our mind, that what this equation represent. Left hand side represent the distance of Z from the point 30, and real part of Z means distance of the point Z from y axis, because if this is the point P having coordinate x plus yi, this is real part of x plus yi, this is imaginary part of x plus yi. It means Z moves such that its distance from the point 30 and its distance from y-axis are equal. And we know that if a point moves such that its distance from a point and its distance from a line are equal, the locus of that point is always a parabola. And this means this equation represent a parabola whose distance from the point 30 and y-axis are equal. That is, this equation will represent this parabola for which focus will be 30 and y-axis will be the directrix. That is, this point will become 3/2 comma 0. And argument of z1 minus z2 is pi/4. That is, argument of B a vector is pi/4. That is, B and A are 2 points on the parabola such that the vector BA makes angle of 45 degree with positive direction of x-axis. That is, the figure formed will be of somewhere of this type, and this angle will be pi/4. Obviously, the equation of this parabola in Cartesian form will be y minus 0 whole square equal to 4 into 3/2 into x minus 3/2. That is, y square equal to 6 into x minus 3/2. And now, keeping this thing in mind, that for the parabola y square equal to 4ax, any point on the parabola can be taken as a t1 square comma 2a t1. The point A can be taken as 3/2 plus 3/2 t1 square and 3 t1. Similarly, the point B can be taken as 3/2 plus 3/2 t2 square comma 3 t2. And to find the imaginary part of z1 plus z2 means we have to find the value of 3t1 plus 3t2. Obviously, the slope of AB will be tan pi/4. That is 3t1 minus 3t2 upon this minus this will be 3/2 t1 square minus t2 square. That is 2 by t1 plus t2. And clearly 2 by t1 plus t2 is tan pi/4. That is 1. That is, I can say t1 plus t2 is 2. Hence 3t1 plus 3t2 will become 3 into 2, that is 6. In this question, he is saying that let z is equal to 1 minus I root 3/2, where I equal to under root minus 1. Then the value of this expression is. Just by looking at the value of z, immediately the value of omega and omega square come in our mind. We know that omega is minus 1 plus root 3i/2, and it is minus 1 minus root 3i/2. Hence, looking at it, z plus 1 by z will become minus omega plus 1 upon minus omega. that is minus omega plus omega square, that is 1. Z square plus 1 by Z square will be omega square plus 1 by omega square, that is omega square plus omega, that is minus 1. Z cube plus 1 by Z cube will become minus omega cube plus 1 upon, that is minus 1, that is minus 2. And now keeping it in mind that Z to power 4 is Z cube into Z and Z cube is minus 1. Hence Z to power 4 plus 1 by Z to power 4 will be minus Z plus 1 upon minus Z, that is minus of, and we have already calculated it is 1, hence we will get minus 1 here. Similarly, keeping this thing in mind that Z cube is minus 1, Z to power 5 plus 1 by Z to power 5 will become, because of this equal to minus 1, as 1. Z to power 6 plus 1 by Z to power 6 will become, looking at it, 2. That is, every bracket will be either 1 or minus 1 or 2 or minus 2. Which one will be 1, which one will be minus 1 and which one will be 2, it is not difficult to observe. And it is also very easy to see that if this is 1, then the next one will be minus 1 and the next one will be minus 2. And in this way, in every group of 3 like it, will be always getting one part as minus 1, second part as 1 and third part as 2 or minus 2. And 2 or minus 2 will come when Z cube or Z to power 6 or Z to power 9 or Z to power 12 etc. are coming. And remaining 2 parts will be always 1 or minus 1. That is, 2 parts will be always getting cancelled. We will require to calculate only this thing when 2 will come and 1 minus 2 will come. And this is also very easy to see that if once minus 2 has come, in next group the last term will be 2 and in next group the last term will be minus 2. Alternately it is very easy to observe. And clearly there will be 7 groups like it. Hence finally we will be getting 21 plus minus 2 cube plus 2 cube plus minus 2 cube plus 2 cube. In this way 7 terms will be there and remaining 6 terms making 3 pairs will be getting cancelled, and finally I will be getting 21 minus 8, that is 13.